Hello again, fellow coders. Welcome to another lesson with Apache Airflow. I'm Praj. I'm a seasoned software developer and a data engineer. In this video, we'll dive into why Kubernetes is such a compelling platform for Airflow, the core tools you would need, and how to set up your environment so that you are ready for the upcoming lessons. In our previous videos, we worked extensively with managed workflows for Apache Airflow, which is a service provided by AWS. Now we are switching gears to Kubernetes, a robust container orchestration platform that offers unparalleled flexibility and scalability for Airflow deployments, or for any deployments for that matter. Unlike a managed service, though, you will get full control. You can fine tune how the tasks are scheduled, rolled out, and scaled up or down. Plus, you can integrate Airflow with your broader Kubernetes ecosystem, making it an excellent choice for teams that need complete customization. But as you all know, with great power comes great responsibility. As we are moving away from a managed service, suddenly you're going to find yourself in a vast pool of options to tune and decisions to make. I'm here to guide you through some of them, and I'll be providing tips on running Airflow on Kubernetes reliably in production. For the agenda of this video, we are going to be talking through the topics I'm going to cover in this playlist. We will be revisiting Airflow's architecture again just to make sure that it stays fresh in our mind. In the later chapters, we are going to look at different combinations on how we could deploy the components on a Kubernetes cluster so that you could scale individual components as your situation calls for it. Then after that, we'll be chatting a bit about the difference between using Kubernetes operator versus using Kubernetes executor. Finally, we are going to set up Airflow on Kubernetes locally so that we will be able to run our DAGs and without paying anything to AWS. Following are the topics that I'm planning to cover in this series. This video, we are going to step into setting up a local Airflow cluster. In the next video, we'll take a look at how the CI process looks like for running your own Airflow cluster. I'm still deciding on the tools I would use as an example. Please let me know in the comments below if you would prefer seeing any specific tools. Then we'll dive a bit into logging and monitoring of Airflow related components when we run them on Kubernetes. We will be using the monitoring tools that we can containerize and run locally. Once we have this set up, we can dive deeper into scaling. Having logging and monitoring is really important before looking at scaling, as we can have an insight on what's going on with our Airflow instance before playing around with performance. Once we know the knobs that we can tune for scaling, we'll look into best practices of running Airflow on Kubernetes in production. Looking at the Airflow architecture diagram, the web server, the metadata database, and the scheduler are always on components. Now, the web server has a web UI wherein users can interact with Airflow, whereas scheduler is responsible for the running all the tasks. Metadata database holds information about all the tasks as well as a lot of other information such as when they were last executed, how long did they take, what is the status, and like everything else. Workers are not always on. Now they would depend on the type of executor that we are running. So if we are running a celery executor, then we would have celery workers that are running that we can actually like auto scale based on the workload that we have. I'll add a link to the page from Astronomer where you can read more about the components down in the description below. Let's take a look at comparing the Kubernetes executor versus Kubernetes operator. On the left side, you can see all the properties for the Kubernetes executor versus the Kubernetes operator, which is on the right side. The difference between them is that the Kubernetes executor, each task runs as a separate pod, where it's easy to set default once and then let Airflow take care of the deployment. This comes closer to a shared nothing architecture where all the tasks end up running separately without sharing resources on one container. Obviously, there are more nuances here as Kubernetes itself can run multiple pods on the same node. But the idea here being container isolation is more restrictive than process level isolation. For Kubernetes operator though,
we are actually running a different executor in the background, using which we can run smaller tasks directly on the worker. While the Kubernetes operator ends up spawning a separate pod. As an example, if we want to call a web service, we don't have to like start a different pod or a separate pod and pay the pod initialization penalty. Instead, we could just run it on an already running worker and then offload the more data intensive task over to Kubernetes. So using Kubernetes operator actually helps in like these situations where you don't have to you don't you don't have to like start a pod each and every time. And if your containers end up being pretty large, then you are better off using like a different executor, because you would always end up like your pod would always take longer to start, because your pod would be pulled down on a separate node. The tools that we are going to use for this chapter, as well as for this whole playlist, are Colima, Helm, and Airflow chart provided by the Airflow community. Instead of Colima, you could use any other local Kubernetes tool like Minikube or K3s. I'm using Colima because I already had it installed, and it makes me easy to set up K3s on my machine. For the Airflow chart, we are going to mostly stick with the default values and only change a few values for us to be able to deploy our DAGs on Kubernetes. I'll be linking the GitHub repo in which I have all the updated values, so that you could just follow along and run it directly on your machine. Let's now set up Kubernetes on a local machine with the help of Colima. For installing Kubernetes on your local machine, here are the commands that you would need. I will also be writing these in the description below so that you could easily just run those. So first you need to install Colima, and then there are two dependencies which Colima has. The first one being Docker and the second one being kubectl. Now that you have both of these installed, you can go ahead and create a virtual machine using Colima with a command like this. Now, because I'm using a Mac Mini with a M4 processor, I need to pass in architecture, as well as I need to pass in this flag, which will allow Colima to run virtual machines on my on my machine. If I don't pass this flag, it's going to complain that it's the wrong type of processor. So make sure you pass that in. Okay, here I am noticing that I'm missing one hyphen here, so I added that in. So what this ends up doing is it creates a directory in your home, local home, with a default configuration. So whatever flags you pass in, you can see that them over here. So the next time, if you want to change anything, you don't need to again run Colima start. Instead, you could just go in here, update the configuration, and then do Colima stop and Colima start again, which would restart the virtual machine. After you run this, you could do kubectl get pods, and it's going to come say that like no resources found in default namespace for you. I'm getting the name like a different namespace because I am using like a different tool which switched my default namespace to be Airflow. You can install that tool as well. I'll link that in the description below too. It's basically it's called kubectx, and once you do that, you could run kubeNS command and then switch the namespace to be whatever you want. So for example, if I switch to default, it's going to like update my active namespace to default, and when I do get pods, it's going to look inside the default namespace. So I'm switching back to Airflow now. To install Airflow, we'll need to add the Helm repo that the Airflow community provides. So for doing that, you'll have to paste this command in. You can find that command in the description below. Now, before actually doing that, what the step which I missed was actually installing Helm. So please like first install Helm, and then you could add that repo in. Once that repo is added, uh, what you would need to do is create a custom set of values. Now these values are like there are a set of defaults that are already available provided by the Airflow community. So I'm going to add a link to that as well in the description below. Now, once you actually paste in the defaults, there are a few properties that we ended up changing. The first property that we changed was the executor. We are going to use Kubernetes executor for this playlist. Then the other thing that we changed was the environment. I just added one for now, which is max active tasks per DAG. We are going to dive more into these particular environment variables when we take a look at scaling Airflow. Now, the next thing that we changed was for DAG processor. What we ended up doing was we enabled them, and what that does is it would run this DAG processor as a separate pod instead of bundling it with scheduler. Then the next thing that we did was set up git sync. Git sync is important so that after setting this up, this Airflow runs git sync as like a separate container, and what it ends up doing is it synchronizes the DAG code with Git, so that whenever there are changes made to the Git repo, it would automatically pull the latest change. Now, for the repo which I have, like it's a public repo, so I don't have to pass in any credentials or anything like that. But if you want, like if you had like a private repo, then in that case, this values file actually has like a template on what you could add to make it easy for you to pull from private repos as well. Now, after updating the values file, we'll have to run this Helm update upgrade command, which would end up installing this Helm chart. Now, I have this values file in a GitHub repo, which I'll be adding to the description below. If you just want to run it locally, you could just pull down that repo, and that values file would be available to you. I went ahead and ran the Helm upgrade command with my custom values file, and it ended up installing all the Airflow components in the Airflow namespace. Now, after it installed, you can see all the values that it outputs, and now we can run kubeNS command to switch our active namespace to Airflow. Once we change our active namespace to Airflow, then we can run kubectl get pods, which would list all the pods that are running in that namespace. And you can see that the Postgres containers, the scheduler, and the web server are containers that are always on. Now, to actually start the web UI, you'll have to copy that command and then run it. What that command does is opens a port to the Airflow container. After running the port forward command, we can head on to the browser and then enter admin as the username as well as admin as the password. Once we hit the sign in button, it would take us in, and we will see all the like the three DAGs which we had written in our previous chapters. The reason that we see the DAGs over here is because we set up git sync in our properties before, and using that, it automatically pulled the latest code for the DAGs from the Git repo. In the next video, we'll write another sample DAG and take a look at CI process of deploying it. Thank you so much for joining in this intro to running Airflow on Kubernetes video. If you like this video, please like and subscribe to the channel, and stay tuned for more hands-on deployments, scaling strategies, and best practices. See you in the next video.